I have today we'll understand Norton's theorem. Okay, so it states that a linear and bidirectional two-terminal network can be replaced by an equivalent circuit consisting of a current source IN in parallel with resistor Rn, where IN is the short circuit current through the terminals and Rn is the input or equivalent resistance at the terminals when the independent sources are turned off. Okay, actually there is no such a big difference between Thevenin and Norton's theorem. Only thing is calculating Rn is same as calculating Rth in Thevenin's theorem, but In is bit different here. So this is the circuit for evaluating our Norton's theorem, and this circuit can be replaced by this simple circuit. Let us understand. Okay, first thing is calculation of In. So in your Viva wise, I will ask state Thevenin's theorem, state Norton's theorem, simple definitions I will ask. Okay, be prepared for that. Okay, next calculation of IN. How will you calculate IN? We need to short our load terminals, right? So load terminal is AB here. So I am just shorting that and keeping the remaining things as it is. Whereas in Thevenin's theorem, what we did, we just open this one, right? We just remove this load in the Thevenin's theorem, but here we are shorting that load terminal. Okay, so okay, now I want you to find out what is IN. Okay, what is IN? So this you can apply KVL. Okay, you can solve by applying KVL. Simple methodology, I used something else. So what I did, I just calculated the effective resistance of these three resistors. I got it as 4. How I got 3 in parallel with 6, you will get 2 ohms, and that is in series with 2 ohms, so 4 ohm. So in total you are having 4 ohm resistance. So 20 amps is coming here, 4 ohm resistance is here, and 4 ohm resistance in this branch also. Overall it is 4 ohm, right? So 20 has to be divided equally because there is a equal resistance in these two paths, right? So 20 amperes here and 20 amperes here. And what will happen next? This 10 amperes, 10 amperes here and 10 amperes here. What will happen next? 20 is divided into 10 and 10, and 10 amperes of current will flow like this. And now what will happen? You can apply current divider rule, right? IN is equals to current 10 at this point, current is 10, right? 10 into resistance in the other branch is 6 divided by 6 plus 3. Okay, so I got a value of IN as 20 by 3, and calculating Rn, what you will do, we'll just open circuit this and you will remove current source, right? Removing the sense you are open circuiting it, right? If it is a voltage source, what you have to do, you have to short circuit. Since it is a current source, I just removed it. So I am left with this circuit, 4 ohm and then 2 ohm, 6 ohm and 3 ohm. Okay, and I have removed load. So what is the effective resistance? So these two are in series, right? 6 ohm in parallel with this 6 ohm. So 6 ohm in parallel with 6 ohm, and then in series with 3 ohm. So 6 ohm in parallel with 6 ohm, you will get 3 ohms. If you solve this, 6 into 6 divided by 6 plus 6, and then plus 3, 6 ohm. So Rn, that is the resistance between these two terminals AB, is 6 ohm, and we got current as 20 by 3. So you can represent our circuit by using this one, where the current is of 20 by 3 and resistance Rn is of 6 ohm, and we have remaining with load resistance of 5 ohm. Okay, I hope you understand Norton's theorem too. Okay, if any doubts you can comment in the comment section. Thank you.